Welcome to my project bazaar.com. Let me discuss about the project Seamless Handover for High-Speed Trains using femtocell based multiple egress network interfaces. Let me discuss about the abstract of the project. Handoff latency is the factor in high-speed train caused with the interference caused by more number of mobile devices. Here, femtocell-based scheme proposed to resolve the long handover latency and poor quality of service in order to reduce the handoff latency factor by MAHO, that is MIMO assisted handoff scheme. Mobile station transmits antenna at one end and data packets at other end, so that the mobile station can hand off without interrupting the data transmission. The interference are caused by more number of mobile devices can be reduced by zero forcing algorithm. Zero forcing equalizer refers to a form of linear equalization algorithm used in communication system which applies the inverse of the frequency response of the channel. LTE femtocell based network mobility scheme with the MAHO, that is MIMO assisted handoff scheme proposed. Initially, genetic algorithm proposed to reduce the interference which caused by the signal from more number of mobile devices. The optimized signals are fed to the femtocell based network mobility scheme used for solving the problem caused by the number of mobile devices, whereas the MAHO is used to reduce the handoff problem by placing the antenna at the tail and head of the train. The interference caused by the mobility systems will be regularized by zero forcing algorithm. Wireless local area networking technologies are widely used in communication based train control system, that is CBTC system. Handoff signaling is lower than traditional schemes when the data rates are not more than 13 megabit per second. The required inter-site distance are analyzed and compared with traditional break before make schemes. A MIMO assisted handoff scheme for CBTC WLAN wireless local area network systems with two antennas or more antennas configured on train and each accessing point. Let me discuss about the flow diagram for our process. This is the train representation. These four represent the carriage of our train. These two are the ending point of our train. In these 2 points, we place the antenna. This is called back antenna. This is called front antenna. And in the carriage, we place the femtocell. In the femtocell, we implement the femtocell based network mobility scheme. Network mobility scheme are proposed a mobility management scheme that move the mobility anchor. However, the algorithm involve the detection and the judgment of the real timing attribute, which is complicated and not suitable for cost-effective implementation. The dense deployment of femtocells, the frequent data path switch operation will cause significant signaling load to the core network entities. Next, in the antenna place, we implement the MAHO algorithm. Based on the MAHO algorithm, we pass the signal to the nearest access point. MAHO is the MIMO assisted handoff scheme and handoff scheme in CBTC system based on WLNS, that is wireless local area networks. Multiple input, multiple output technologies to improve the handoff latency performance, channel estimation errors, and trade-off between MIMO multiplexing gain and diversity gain in making handoff decisions. The handoff problem is formulated as a partially observable Markov decision process, and the optimal handoff policy can be derived to minimize the handoff latency. The handoff problem is formulated as a partially observable Markov decision process. Handoff is processed to take advantage of the fact that the train in CBTC system can acquire its locations accurately in real time. The MIMO transmission mode will switch to multi-user multiplexing from a single user STBC transmission mode, which will degrade the transmission performance. To determine the optimal handoff location for the multiple antenna configuration, we suppose that the handoff happens at the place where the fear of data transmission with the serving accessing point is some FER of the transmission of handoff signaling, which are transmitted between the train and the candidate access point. Next, in order to improve the Maho algorithm, we propose the zero forcing algorithm. Zero forcing algorithm or interference nulling algorithm refers to a form of linear processing algorithm used in communication system which nulls out interference signal in the time domain and inverts the frequency response of the channel in the frequency domain. If the channel response for a particular channel is high, the interference nulling algorithm multiplies the reciprocal of h the input signal, which removes the effect of the signal from the output signal. Finally, we analyze the performance. Performance analysis estimated between handoff latency for existing and proposed algorithm, which achieve low latency. There is also estimated the bit error rate for with respect number of users and the speed of the train. Finally, achieve the low data losses, even speed of the train and the number of users increased. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, right-click that file and run for executing this process. This is the train representation. This blue color indicates the track of our train, and these all the represents the carriage, and this red color triangle represents the femtocell, and this blue color represents the Maho scheme, and green color represents the access point which we need to transfer our data. And this is the BER representation, that is bit error rate representation for transmitter and receiver graph, and with respect to the EB number. And this is a plotting graph representation. This is the overall MMSE and least mean square error and mean square error graph for every channel with respect to EB number. And this is the handoff latency graph between existing and the proposed system. Here we use the existing system as MEN NEMO scheme, and our proposed system is MAGO. Here the graph between velocity of train, that is speed of our train, and also handover latency. And this is represent data rate. Here we achieve the data rate as 8 megabit per second, and in the existing system we achieve the data rate as 3 megabit per second. And this is the received signal strength in a megahertz format. Here we achieve the proposed system, we achieve the 8 megahertz as the received signal, and in the existing system we reach the 6 megahertz. This graph between velocity of train, and this is the handoff latency between number of user. If the number of user increase, the handoff latency will be gradually stable. And this is the interference graph between interference versus number of users. This graph will be plotted for MAGO and NEMO scheme, that is existing versus proposed. And this is the handoff latency versus average satisfaction score. So if the active user increase, the average satisfaction scores will be stable, that is constant. Finally, the efficiency of the process is improved. The final simulation output shows that proposed Maho method can reduce the handoff latency well. Thank you.